Hello everyone, welcome back to my channel. In this video, in this session, we are going to talk about the RAG evaluation metrics. So if you have a RAG mechanism implemented, so how do you evaluate that? So there are certain metrics to judge that, and we are going to evaluate those metrics in this video, in this session. So there are many metrics available, there are some standards available. So that we are going to evaluate, we are going to use one library, one package called as RAGAS, which is RAG assessment package or a library. So let's get started. And before I start, if you go to my YouTube channel and if you go to the playlist section, this is the playlist section and this is the playlist AI generalist. So here I have so many videos which are talking about RAG, preparing RAG projects, different types of RAGs, what are the different uh, internal stages of the RAG, and also one video on the test data generation or synthetic test data generation for testing your RAG. So this video is going to be extension of the same. So let's proceed. And whatever code I am going to explain, so the code is available here and the link is in the description. Okay, so we are going to talk about these are the metrics. So MRR and DCG, precision at K, recall at K, BLU, rouge, and like that. So let's get started. So as I said, RAG evaluation metrics. So there are different metrics available in market, and we can choose what is the exact thing what we want, what is a particular need for a particular situation. Okay, so let's get started. So MRR being the reciprocal rank. MRR measures how well the retriever ranks the first relevant document in the search result. So there are certain points to it. So let's see those points. MRR is a critical metric used to evaluate retriever component. It specifically measures how well the system ranks the first relevant document in its list of search result. Okay, so yeah, so there's a core definition: ranking sensitivity, binary relevance, scoring range, user experience focus. Okay, so let's see those first here. So the core definition is MRR is basically 1 upon R1. So average of the reciprocal ranks. Binary relevance, something which is relevant, which is not relevant. Score example. So so let's say there are certain documents which are relevant, but this is not relevant. So the relevant will be having a good score and non-relevant will be having very less score. Let's say less than 0.5 or zero point 0.4. Ranking sensitivity, yes. Scoring range and user experience focus. So there is a program here which is for mean reciprocal rank. Okay, and before I run anything in this automation, I want to specifically mention that I'm using RAGAS 0.2.2 because the advanced libraries has some breaking changes, and I found that 0.2.2 version is most suitable for this particular need. That's why I'm using this, and all other library specific versions I've mentioned here. So make sure you use the same exact version. Okay, so mean reciprocal rank. Okay, by the way, I'm using Olama AI model provider here. So I have installed Olama and I have logged in with my personal account, and I have to initiate certain things so that this embedding model I'm using. Embedding model I'm using the popular one, Nomic Embed Text, and the general model I'm using this one, and other technicalities. Okay, so let's consider. So I have certain documents. Okay, so there are certain documents which are having different domains. So one is in art, one is in science, one is in programming or software, and this is some geography. Okay, so these are the four documents which I'm going to use, and I'm going to evaluate the mean reciprocal rank. So there are certain things I need to follow. So I need to have character text splitter, and then split the documents. Each document I have to split. Then I have to use the vector. I have to store it in a vector. So FAISS is the one storage database I'm using, database storage. Retriever. So as a retriever, I want to find the similarity. Okay, and the top three similarity. So fine. So vector store is initiated, retriever is initiated. Now what are the queries? So there is a RAG, and I want to ask some question to this RAG. So these are the queries or questions. Okay, so who wrote Hamlet, capital of France, and the who developed the theory of relativity? Okay, I have the model answers. Okay, right. Now, yeah, so mean reciprocal rank method I need to call. Right, so these are some technicalities. So this is the code which will give or evaluate the MRR. Okay, and there is a function here which is reciprocal rank, which will actually do the reciprocal ranking related truth, or I mean the score calculation. Okay, so let's run this first. So we know the query, and we know the reference content. Based on that, what is the RRR, I mean MRR given to us. So that is what I'm trying to say here. Yeah, so this is the query, this is the retrieved response, and relative ranking is 1. Okay, so this is the first one. So this is the how relevant, basically uh, ranks the first relevant document in the search result. So that is what, this is the first search result. Okay, Hamlet, then France. So this is the, among all the documents, this is the one which is the nearest match. Relativity, so yes, this is again the science related. Yes, so each individual relative rank is 1. Okay, which is good, and final rank is also 1.00. So that is very ideal situation. Okay, now let's introduce some error here, and I'm going to use a different document set. Okay, so this is a different trial where uh, okay, so I have a different document which is basically contradicting or something which is not relevant. Okay, so though the reference is changed, okay, the reference is changed by the capital of France is Istanbul, and William Shakespeare wrote Pokemon and whatever, right? So the questions remain the same, but now answers are not relevant, or not, or basically confusing. So let's see what is the score. Okay, so this is to see how well the MRR works for us, because happy path, earlier we have seen the happy path, which is fine, but if there is a different data set, then there is a mismatch between data set and the queries, and that is what we are going to see. Okay, so if you see, it is not relevant. So Hamlet, there's no mention of Hamlet, but then wrote, that is something, writing a book or something, so wrote. So this is the relevant match. Okay, that is why RR is 1.0. Okay, capital, so capital is matching, but you see the final answer is not matching, so something similar but not. So these are all not even close, but this is seems to be close, but still the RR is 0. Okay, then the relativity, so theory of, so the same, it think, it I think the words are matched, that's why RR 1.0, but overall if you see, it is quite reduced from 1.0 to 0.66. Okay, so this is how we will have to evaluate the RR, I mean the mean reciprocal rank for a particular given rank or particular given situation. Okay, right. So this is about the MRR. Now let's see the NDCG, normalized discounted cumulative gain. Okay, so let's proceed. NDCG measures how effectively the system ranks relevant information crucial for RAG systems to find the most important context at the very top of the retrieval result, at the very top of the retrieves. Okay, so there are certain points to it. So relate ranking the quality, graded relevance. Okay, then positional sensitivity and normalized aspect, and human behavior alignment. Okay, so NDCG is a gold standard metric for evaluating the retrieval component of RAG system. So remember, this is for the retrieval. Okay, so RAG has retrieval augmented generation. So this is about the retrieval. So it measures how effectively the system ranks the relevant information, essentially because RAG performance drops if the LLM cannot find the most important context at the very top of the retrieved result. Okay, so these are all are the evaluation metrics. So we are going to see that how better the RAG performs for a particular query or particular question, and it will analyze the data set and give us the answer or response. Okay, so same thing, ranking quality, uh, positional sensitivity, graded relevance, normalized aspect, and human behavior alignment. Okay, right. So we can go through this technicalities in detail, but I'll show you the simple code. So let's say that we have a rack system where uh, there are documents and there are number to the documents, and we are going to retrieve it. So let's say these are the numbers or the indexes of the uh, uh, documents, the one documents what we have seen here. So something like this, so document 1 2 3 4, right? So these are the index, that is why these are the index. So this is the true relevance, and your RAG predicted this relevance. The RAG, this is the RAG score. So true relevance score for a set of retrieved documents, uh, predicted score relevance for your RAG from your RAG retriever. Okay, from this is your RAG retriever output, and calculated NDCG. So by default, it considers all result using use K to simplify NDCG at K. Okay, so basically it's playing with the indexes and how close or how relevant are the indexes compared between true and the predicted. So that is what it is going to produce. Okay, so by default it considers all the results, use K to specify NDCG at K. So I want to have top three results, or consider only the uh, three items, right? Okay, so NDCG score is a direct method in the sklearn package or a library, which you can see. Okay, so compute normalized discounted cumulative gain. So this is a standard practice, standard method used in statistical analysis and many other places. So that is why we are using the same thing. Okay, right. So NDCG score for k equal to 3, and also we are going to seek for k equal to none. Okay, so yes. Okay, so the score is 0.8950, which is bit good. Okay, uh, as compared to the true and the predicted score, right? Okay, so let's see the next one, which is NDCG equal to, I mean k equal to none. So I don't want to refer any items here. I was referring 3, now there is no. Okay, let's see just for the different perspective. So note down 0.8950 was the early score, and if you see now the score is improved 0.9808. Okay, so we need to keep on try some different things and see what works and what doesn't work for a particular situation. Okay, right. So now let's see the precision K. So next matrix is precision K. So it is a measures the accuracy of top k results, determining what fraction of the first k result. So top k result and the first k retrieved documents are actually relevant to the user's query. Okay, so slightly different, almost same but slightly different as compared to the earlier matrices. Okay, so there is a formula. We will not go into detail of the formula. So signal to noise ratio, order, unaware, precision K, impact generation, binary relevance. Okay, so we'll see some theory here. So it measures the accuracy of the top results by determining what fraction of the first K retrieved documents are actually relevant to the user story. Okay, right. So again, there are some other explanations, so other points. So signal to noise ratio, impact on generation, order unaware, binary relevance. Okay, all right. So let's run the program for precision K. So right. So here we have other aspects. So we have something called as ground truth. Ground truth relevant document IDs for a specific user query. So again, the same thing if we did for the MRR. There we had some documents. We raised a query, and then we know that these are the reference document or the reference. What do you say? Chunks from where the data should be retrieved. These are the top chunks and all. So this is, let's say, the ground truth, where for a particular query this is the sequence of the document numbers to be considered, and this is one from your RAG retriever. Okay, so these are the ground truth, these are the retrieved results, and we have to see how checks the first three result, uh, and we have to see how they are precise. Okay, so precise right? It measures the accuracy of the top key result by determining what fraction of the first k retrieved documents are actually relevant to the user's query. Okay, so yeah, so what this method is doing, um, calculates the precision at k matrix. So a set of ground truth predictions and the cutoff rank it returns. Okay, so slice the list to only include the top k result. Okay, so yeah, prediction should be sliced to only first three result, and count how many of these top k items exist in the actual relevant set. Okay, right. So little bit of mathematics here. That is okay, but it is going to give us the precise k. So I'm going to check for first three here and first five results, cut off. Okay, right. So precision three. So check three results and check five results. So let's see. So for the top three, the score is zero point 0.6, and for the top five the score is zero point 0.4. Okay, so obviously if you increase more and more reference or the retrieved documents to compare with the ground truth, then the overall average score will drop. So we have to see whether we have to go very large number of results or less number of results. So we need to find some optimum number. Okay, right. So moving on to the recall at k, almost similar. There is some mathematics involved here. Okay, uh, yeah. So let's see the theory first. Recall at k measures the proportion of relevant documents successfully found in the top k results compared to the total number of relevant documents available in the dataset. Okay, kind of similar to precision at k, but little bit different. So it is recall and that is precision. Okay, so there's something called as north star, basic formula, completeness over accuracy, rank, insensitive nature, and common values for k. Okay, so these are the values. So we are going to see for 3 and 5, but it can be 10 if it's a very complex a rag with hundreds of documents we are going to refer. So it might, we might need to increase the count, the reference count, benchmarking count. Okay, right. So some theory. So it measures the proportion of relevant documents successfully found in the top results compared to the total number of relevant documents. Okay, yeah. So north star, completeness or accuracy, basic formula, and there is some theoretical explanation here, which you can see later. Right. So let's run the recall key. So yes. So for recall k, right, so if you have recalled only 1, 3, or 5, 10, so if you see, the overall matching, I would say, overall um, matching percent or retrieval percentage is increasing. Okay, the score is increasing. So we have to find the optimum score. Okay, right. Now moving on to the next one, which is blue score. Okay, before that I want to also talk about this additional metric, so single turn sample. So here basically what we are doing is we are testing the rag, and we are going to pass some input and get some output, basically response. So here we can have single uh, single turn sample, we can have multi-turn sample and those things. Single turn sample is basically one set of questions. Okay, just one set. Okay, so I have an input, I have retrieved documents from the rag. This is the actual rag response and this is the rag reference. Okay, so for this basically single set of everything, single set of question answer and references. And that how do we combine? Okay, there's something called as evaluate method. So this is again from RAGAS. Okay, so RAGAS is a package or a library which is very helpful to evaluate RAG and LLM, basically anything which AI responds and those things. So that uh, to evaluate we can use the RAGAS library. Okay, also explain the same in this earlier video also. Okay, yes. Now define single test case, then wrap your sample into a data set. Okay, simple data set, and you need to call the evaluate method. So data set from this particular dictionary. Okay, This is a key value pair, so that is all the dictionary, and we are going to evaluate. So in the evaluate method, we need to pass the data set, we need to pass the LLM. So LLM is this one. I'm using the GPT OSS 120 billion parameters AI model, and this is the Olama LLM I'm using. Make sure in this entire video, your Olama should be installed. It should be logged in, and you have sufficient credit in the Olama. Okay, right. So we need to pass the metrics also. So these are the standard metrics: faithfulness, answer relevancy, context precision, context recall, and so on. So these are the typical four used in many places for evaluating RAG. I mean, typically the first thing what we evaluate in the RAG is all these four uh, metrics. Okay, others are also there, blue, rouge, and other things, but this is the main thing. That's why I kept it at the middle of the video. Okay, so as the name says, I want to know the faithfulness of the response. What is the relevancy answer of the answer, precision, and context recall. Okay, so I have a set. I have a data set. So input, context, response, references. So that is what I'm going to evaluate. So in the evaluation, I can pass one metric or multiple metric. Okay, and many other metrics. So I'm going to show one example of these three metrics. Okay, now the thing is, you can pass on multiple samples. Okay, you can put this in a for loop and those things. Otherwise, we can have something called as a multi-turn sample. So that is also possible, which probably we'll see later. But yes, if you want to do single, then go for this way. Okay, right. So let's run this, and finally we are going to have the result scores. Okay, so let's run it. Three metrics. So we are going to use three metrics to analyze the RAG result. Okay, so it depends on practical need. If you want to use only one metric, two metrics, three metrics, or n number of metrics. Okay, yeah. Now one thing as a caution here, this RAGAS library. Okay, I'm using a bit old version 0.2.2. It might break sometime because they will they will always encourage to use the latest library, but I'm using this old one 0.2.2, which is a bit stable. Okay, right. So for this particular set, okay, I see the faithfulness is 100%, and for answer relevancy is none, and context recall is none. Okay, now answer relevancy is none. Okay, that matrix is not good. uh, okay, it might be some technical reason. Okay, so there is some warning here: authentication error, incorrect API provided. Fine. This is about the open AI API keys. Okay, so as I said, I'm using the AI model which is from Olama. Okay, uh, yeah, Olama model I'm using. Okay, these are all Olama model. And so what is happening is, in a lot of RAG evaluation libraries, by default, uh, there is a trend that it will use the open AI models. Okay, which is good, but it is a paid one. So I don't want to use the paid one. I want to use something which is good enough. So that is what I'm using, the Olama AI library. It is also paid one, but there are some credits which are free. So that is why I'm using the free credits. Okay, and I'm getting 120 billion parameter AI model for my particular use, and that too for free for certain time. So that is why this error message. Okay, right. Okay, so we can go on for multiple metrics and on and so on. Right. Okay, now proceed to the next one, which is BLEU. Okay, BLEU, bilingual evaluation understudy. So it was originally built for machine translation. BLEU is a common baseline metric for evaluating generation component. Okay, or generation component of the RAG pipeline. So far we have seen RAG, so retrieval augment generation. So this blue is for generation related evaluation generation component. Okay, right. So there's a precision oriented, n-gram overlap, brevity penalty, blue. Uh, this is a formula, fast and cheap, and candidate answer and right. So these are certain points to learn about the blue. Okay, so it was originally built for machine translation and so on. Precision oriented, n-gram overlap, brevity penalty, fast and cheap. Right. Okay, so we can go through this later, but I will show the actual code. So here I'm using again the same singleton sample. Okay, so simply I need to provide what is the response for a particular query and the reference for the particular response. Okay, right. I can also provide the reference also, but that this reference also. But let's see, we'll see it later. Right. So I'm going to use the non-LLM string similarity here, and I'm going to use the distance measure as Hamming, uh, I will be running this you know this I will be running the evaluation for this particular score, right? So blue score is a metric used to evaluate the quality of the responses by comparing it with the reference. So blue score is a direct method in the RAGAS library. Okay, RAG assessment RAGAS library, and I'm going to run the score and for this particular sample. Okay, this is the sample. Okay, and same thing I'm going to use for a tuple of float weights for unigrams, bigrams, and trigrams. Okay, right. So in the this particular blue score, I'm not passing any weight. Okay, I'm not passing any weight. Basically, it will take the default weights, and I'm passing some specific weights. Okay, and then let's see the score. Okay, okay. So yeah, so the score for the first one is 0.88, 0.75, and 0.883. So this first and third seems to be good score. This seems to be a good score, which is using non-LLM string similarity. This is by default blue score method, and this is the blue score with the particular weights. Okay, so this basically using the default weights. This is using some custom weights, right? So this is a fixed code. All we have to do is we have to generate different samples based on the questions what we have, the response what we get, and we'll get the blue score. Now, just one thing I will change. I will change the reference. Okay, so the response is this, but the reference is not matching. Okay, those are totally irrelevant. Okay, now let's see the score. Okay, so remember first these are the score 0.88, 0.75, 0.88, and well, okay, so we got a warning. Fine, that is okay. So the score was very different from the one what we anticipated. Okay, so first is 0.13, which is not a good score. Something which is less than zero point 0.5, zero point 0.6 is a bad score. So this is not relevant, not a good score. This is also not a good score. This is also not a good score. So if you see, so there is a RAG, there is evaluation matrix, and we are going to evaluate the matrix itself, right? So this blue score matrix will is showing that the good results if the reference and the response and the reference are good, and also showing bad results because the reference and response are not relevant. Okay, so I mean the score is bad, but it did what we wanted, right? Okay, fine. So let's proceed for the rule score. Okay, this is also one of the good evaluation metrics. Okay, Rouge matrix. So a set of metrics primarily used in the RAG to evaluate the quality of generated answers by comparing them with one or more human written reference answers. Okay, so something which is human in the loop in the picture. Okay, so primary focus on recall, Rouge 1, then we have Rouge L, we have Rouge 1 unigram, and Rouge 2, there is Rouge 3, Rouge S, Rouge skip diagram. So many other small units, I mean small components are there. Okay, so it is a set of metrics primarily used in the RAG to evaluate the quality of generated answers by comparing them to one or more human written reference answers. Okay, primary focus is on recall, Rouge 1, Rouge 2, Rouge L, Rouge S. Right. So many aspects are here. Okay, we can go through this theory later also. You can just pause it and you can see. But let's see the actual demo. So Rouge score. Okay, I need to call this Rouge method, Rouge score method, without any weightage and without any parameters, and here also with some parameters. Okay, so I'm going to use Rouge 1 here. Okay, based on the different needs, we can go for Rouge 1, 2, or whatever things mentioned here. Okay, Rouge 1, Rouge 2, Rouge L, Rouge S, and so on. Right. So we have seen here singleton sample response and the reference, and we are going to see the score for default and for custom Rouge score. Okay, right. So let's run it, and there's no LLM, nothing is required here. Okay, so 0.875 is the score. So seems to be a good score for both the method calls. Let's do one thing. Let's change the reference. Okay, so these are not relevant also. So let's see what happens. Okay, so score is not good. So which is perfect what we want. Okay, because we messed up with the references. Okay, so these two are not even matching, so the score will obviously reduce. Okay, something which is not if the score is, let's say, less than 0.5, 0.6, or 0.4, anything less than this is a not a good score. So fine, so we have evaluated the Rouge score also, right? Okay, right. So you have seen the demo and everything, right? So yes, these are the various different metrics which are used to evaluate RAG, and we evaluated the metrics also for particular need. Okay, fine. So thank you very much, and if you like the content, if you like the channel, please like, share, and subscribe to my channel and videos, and press the bell icon. Thank you.